Hi everyone. In this video, we are going to look at how to find 5-number summary and how to draw a box plot. Now, this is part of describing data in statistics. So after we collect raw data, we want to organize data and we want to describe data so that we can extract information from the raw data. And 5-number summary is a way to describe data. In this 5-number summary, we're going to find these 5 numbers from a data set. And these 5 numbers are the smallest value in the data set, the largest value in the data set, the median of the data set, and the quartile number 1, or the first quartile of the data set, and the third quartile of the data set. The second quartile is the same as the median. So usually we don't see the second quartile, we see the median. And so these are the 5 numbers. So it's a way to summarize, to describe the data set. Now let's look at an example here. For the following data set, we have 2 of those. Calculate the 5-number summary and find the IQR. Later on, we mentioned the meaning of IQR. So we have this data set. And since 5-number summary includes the smallest, the largest, the median, the first quartile and the third quartile, before we can answer those questions, we want to put these numbers in order from the smallest to the largest. You can do it from largest to smallest, the result will be the same. So usually I go with from the smallest to the largest. So let's line them up before we answer those questions. So let's see, later on I show you how to do this using Excel, which is much more efficient to do this kind of calculations. So I need to identify the smallest. So I just look at the first digit, two-digit numbers. So apparently the smallest 10. Then I cross out so that I don't need to get distracted from that number again. So do I still have the double digit starting with 1? No more. Now starting with 2. No, 3. Now 4, there's no 4 either. 5, this is the smallest. So 50. Do we still have other numbers start with 5? No. Now let's start with 6. 65 is one of them. Yeah, that's the only one. So 65. Now 7. Start with 7, 73, 73, 79, 78. So 73 is smaller. I have 2 of those. And 79, 78. So 78, 79. So these 2 are gone. So make sure we don't miss any 70s. Yeah, that's it. Next one, 80. Started with 8, 85, 84, 89, 83. So 83 are apparently smallest. 83, then 84, 85. Double check to see if there's any 80s left. 89. Any more 80s? No more 90s now. 97, 92, okay, 92, then 97. So make sure no more 90s. Yeah, only one left, that's 100. So make sure we don't miss any number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14 numbers. So we're good. Now, after we put them in order, we can answer these questions. First, the smallest apparently is 10. That's why we line them up first. Now, second number we can do is the maximum value in this data set, which is 100. So put here 100. So the max value of 100, we have 5 numbers, right? 1, 2, 3, 4, 5. We just summarize this data set using these 5 numbers. That's called 5-number summary. Now, the first calculation we can do is the median. This tool, you don't need a calculation, the median. Median, by the definition, is the number sitting in the middle of an ordered data set. That's why we order them. So we are looking for the number in the middle. Now, since we have 14 numbers, which is an even number, for even number of numbers, there will be 2 numbers sitting in the middle. We learned that in the last video, calculating statistics. So since we have 14, now there's a median location formula to tell you which one is going to be your median. That formula is n plus 1 divided by 2. N is how many numbers in the data set. We have 14. 14 plus 1 divided by 2, that's 7.5. So this is just another indication that you're going to have 2 numbers in the middle, because our median is this location formula. Our median is sitting at 7.5 place. How come you have decimal? That's just indication you have 2 numbers. You need number 7, you need number 8, and you need to add those 2 numbers together divided by 2, you get 7.5 place. So number 7 and number 8. 1, 2, 3, 4, 5, 6, 7. We need these 2. To see, double check if these 2 are in the middle. We have 1, 2, 3, 4, 5, 7 in the front. 1, 2, 3, 4, 5, 7 after that. That's why we call them in the middle. So the median is 79 plus 83 over 2. So if we do that, and that's going to be 81. So the answer is the median is 81. Now that means a median is in here, sitting in here, is hidden. Okay. Now, what is the quartile number 1? The whole word for this Q, quartile, Q-U-A-R-T-I-L-E, quartile is the same as quarter. So quartile number 1 really means 4th quarter of data. Now, which by definition is the median of median. Median is in the middle. Median cuts the whole thing into 2 halves, right? Now, quarter is half of half. That's why when we need to calculate the quartile number 1 or first quartile, we want to find the median of the first half. Half of half, that's quarter, right? So in other words, we need to find the median of these numbers up to 79, because the first median is here. We need to find the median of the first half. Now, how many numbers we have? 1, 2, 3, 4, 5, 6, 7. For our number of numbers, there's only 1 number in the middle. In this case, is 73. So quartile number 1 is 73. Now, quartile number 3, first quarter, second quarter, third quarter, right? Quartile number 3 is the median of the second half of data. 1, 2, 3, 4, 5, 6, 7. So this one is in the middle. 3 in the front, 3 after it. So quartile number 3 is 89. So we just found the 5-number summary for this data set. Now, the other one is called interquartile range. So this IQR really means interquartile range, which is by definition equal to third quartile minus first quartile. That's definition. So our third quartile is 89. Our first quartile is 73. So if we do subtraction, this is 16. So our IQR is 16. So what this means when we have this quartile number 1, quartile number 3, quartile number median, right? Basically, we want to describe how concentrate of this data. We want to now say later on, actually we can mention it here. Since this distance for the IQR is the distance between quartile number 1, quartile number 3, which represent half of all of the data, 2 quarters, between quarter 1, quarter 3, that's 2 quarters, which represent how spread your data, original data in your data set. Say this is 16 point apart from the lowest value to the highest value for the middle 50% of the data. Now, this is how to find 5-number summary. Now, before we move on to the next example, let's look at how to use Excel to find the same 5 numbers for the exact same problem. So I'm going to bring up Excel. So now this is Excel, and let's look at our first data set on the left side. I just type in these numbers. We just finished in our example. Now I'm going to calculate these values, including IQR. Now first, this is the original data set. I need to put them in order, right? After you type in this data, you have to type them in a column, not a row, okay? It's very easy to put them in order by using sort function. So I'm going to highlight this data set and right click. There will be a sort function. Say sort from the smallest to largest. See, it's already done. Now let's undo that in case after you do right click, you don't find the sort, you can find that function from this function ribbons on the top of the Excel. So I'm going to roll it back to redo that. So this is the original data set. Now, first the button you need to click should be, yeah, there's another one on the right up corner here, sort and filter. So let me highlight this data set, sort and filter, click this down arrow, see, you have this one. We will get the same effect. See, that's it. Now let's find this 5-number summary. And first, apparently this is 10, you can type in here. You can just click equal and click this cell that contains 10. Enter. Now max value equal to the last one here. Click on that. Again, you can type, it's just 2 numbers. Now let's calculate the rest. Always calculate the median first. So equals. And to do that, we need to use median function. Just type median. But you have to start with equal sum. Make sure you do that. Now select all of these numbers and close the parentheses. So we know that's correct. We got the same number when we did it on paper. Now median is 81. 81 means it's between 79 and 83 because this one 81 is bigger than 79, smaller than 83. It's in here. It's in the middle. What this means is that 79 belongs to the first half and 83 belongs to the second half. So I'm going to highlight that, just make sure you see that. This is the first half and this is going to be second half. When you do this using Excel, you don't have to highlight that. I'm doing this for the video, so it's very clear, everybody can see that. Now, quartile number 1 is nothing more than the median of the first half. So all I need is use this median function one more time. So highlight first half. So 73, we know that's correct. And quartile number 3 is median of the second half. and supposed to be 89 from our paper. So that's 89. Interquartile range, so you can use a Q3 89 minus 73. So I just click the cell contains Q3 minus quartile number 1. So 16. So this is the exact same results. Okay, let's switch back to our paper. Let's look at another example. Okay, move on to the next example. So we have a new data set, and we want to calculate the 5-number summary. And first, the reason we have second data set, second example is that in the last one, we have 14 data points. In this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is an odd number. So we want to show how to get 5-number summary if you have odd number of numbers in your data set. But either way, we need to line them up, right? Let's do that. Apparently, smallest is 6. And the first digit being 1, we just have 18, 19. Yeah, 2 of them. 18, 19. So there are no more ones. Now let's look at 2. 28. Now only 28. So this is gone. Now let's look at 3. 34, 37, 35. So 34, 35, 37. Double check. No more 30s. Okay, 40s. 45, 44, 42, 48. So 42 and 40, 44, 45, 48. Any other night left? No. Make sure it's 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. So for the our number of numbers, there's only one number in the middle, and there's not many. We can just visually look at which one is the middle. Otherwise, if you want to use the median location formula, that's perfect fine. So we have 11 numbers, n plus 1 over 2, get 6. So number 6 is our answer. 1, 2, 3, 4, 5, 6. So the median is 35. So you can see that there are 5 numbers in front of it and 5 numbers after that. That's called being in the middle, right? The minimum is 6. The maximum is 48, apparently. 48, right? So now all we need is calculate quartile number 1, quartile number 3. So quartile number 1 is the median of the first half. This is the first half. Apparently 19 is in the middle. So 19 is quartile number 1. And the second half, 44 is in the middle. So 44 is quartile number 3. And interquartile range equals quartile number 3 minus quartile number 1. So 44 minus 19, and that is 25. So we finish it. Again, we are going to show you how to do this using Excel. No fundamental difference. Let's just go through that. So this is Excel, and this is data point. Again, I already typed. So first thing I need to do is sort this data so that they line up for the smallest to largest. You can do again from largest to smallest, no difference. Sort. Yeah. Apparently smallest is the 6. I just you can directly type 6 because we don't do anything other than that. Just one step procedure. Either way is okay. But usually I just click. Second one, largest, and median equals using median function. Select all of this data, and you get 35. Now, let's look at quartile number 1. So 35, let's slow down a little bit. 35 is a median. Let me color this one. So 35 is a median. Now there's a small issue here. Where do you put this 35? Do you put it so that it belongs to the first half, or do you put it so that it belongs to the second half? The answer is neither of those, because if you use the 35 as the first half, actually first half has 6 numbers as a result, and the second half only have 5. That's not even in the middle anymore, this 35, because the middle means that both sides have same amount of numbers. If you put 35 so that it belongs to the second half, you create the same issue. Second half will have 6 numbers, and the first half only has 5 numbers. Again, that's not being in the middle anymore. So 35, you cannot even call it a median anymore. So how to solve this dilemma, basically? The way we do that is that if you have an odd number of numbers, as a result, you have one single number in the middle. When you calculate quartile number 1, quartile number 3, you simply ignore 35. So we only use this part as first half. And this is the second half. So you can see this way we have equal number of numbers in either side, right? 5 numbers, 5 numbers. Okay. Now, same thing on paper. I didn't explain that when we did it on paper. And so now quartile number 1 is the median of the first half. So I have like simple. Imagine you don't have just first and so equals in and range 3 and if everything is good. But topic is we're going to draw a hey, somehow it got disconnected. Let's continue. This section, this part is about how to draw a box plot, which is a visual representation of 5-number summary. And see, we have a number axis here. So basically, we're going to draw this box plot using this axis. And we're going to do that using a Microsoft graph program called Paint. And you can do it by hand, but try to make it more professional using a graph like this, not hand draw lines, which is not very straight actually. And make sure when you turn in your homework, it has to be in one of those 4 formats. And for the graph format, you could have a JPEG and 3 different image files. Extension is on the Blackboard or PDF file. So now let's go ahead and look at how I create this box plot using Paint. You don't have to use that program, but if you have a Windows machine, you will have that program. It's pre-installed. Every Windows machine has that. Okay, this is the 5 numbers that we are going to use to create that box plot. Now I'm going to display the penned program. Say I already have this axis preloaded, and if you download this from homework website page, and you just open this graph using this pen, you will have it in here. Now, how do we do that? First, I need to draw that box. Box is the inter quadrant range, basically. If we look at which is from quartile number 1 to quartile number 3, right? So from 8 to 16. So I'm going to select this rectangle because we are going to draw a box. Select rectangle here, rectangle, highlight it. And from 8 to 16, here's 8. Try to draw a box, rectangle. 8 to 16. You control the width of this box. As long as it looks neat, everything is good. So I get a box already. Now I still have this median, which is 12, here 12. All we need is draw a bar. Bar is this line. So click this line, select this line. At 12, draw a bar. Make sure it's straight. Try your best. Yeah, that's median is 12. Now we still have minimum and maximum, which is just a point. You can draw a small bar also if you want. So minimum is at 4. Try my best. That's 4. And the maximum is 17 here. 17. Try to draw at the same level as your box. 17. Now finally, you need to connect from this two extreme values to your box and try to do that in the middle. You don't have to be perfect, but just try your best. Yeah, basically that's it. That's called 5-number summary. So with this axis, people can read your 5-number summary. Max is 17. People know when they read it, the first point at the very left end is the minimum. The beginning of box is quartile number 1. Middle, the bar in the middle of the box represents median. The ending part of the box is quartile number 3. The very end to the right is a maximum value. So when you have this scale on the x-axis, horizontal axis, people can read your 5-number summary. And after that, you just need to save it. Save it as a image file. And that's all for this box plot graphing part. So let's go back to our paper. So our next topic, identify 5-number summary after you have a box plot. In other words, you're given a box plot, you need to be able to read it to identify the 5-number summary. 5-number summary. So let's do that. So this box plot, this is the scale. Apparently, the very left end represents the minimum, which is 0 in this case. And the left end of the box is quartile number 1. And from the scale, we can say it is 10. And the median is a bar in the inside the box, which is 30. And the right end of the box represents quartile number 3, which is 55. The maximum value, 75. So it's very easy to read. And what is the IQR? So IQR equals quartile number 3 minus quartile number 1. And when you answer questions on the Blackboard page, you don't need to write this, you just write the result. So we got 55 minus 10 is 45. Okay, that's how we read 5-number summary from a box plot. And next topic, let me mention this quickly. This is the same chart that I will just answer that question on the last page. So what is the difference between quartile, what is the percentile, and what is the spread after you have this box plot? First, there's really no fundamental difference between quartile and percentile. For example, this one represents quartile number 1, right? And which is 10. So quartile comes from the word like quarter. The whole data set is cut into 4 different quarters, from beginning to the first quartile, fourth quarter, from here to here, second quarter, from here to here, third quarter, from here to here, fourth quarter. So you have 4 quarters of data. Each quarter represents 1/4 of all of your data. It just have different ranges. For example, you have 1/4, which is 25%, by the way. You have first quarter of all of your data, or 25% of all of your data, whose value are between 0 and 10. And the second quarter of data, that means from 25 to 50. Second quarter of data has value between 10 and 30. Apparently, second quarter of data are much more spread out than the fourth quarter. All of those 1/4 of your data are concentrated between 0 and 10. But second quarter, you have same number of numbers in it, but spread out much wider. It's from 10 to 30 in terms of value. And the third quarter of data, even wider than that, is spread from value being as low as 30 to as high as 55. Each quarter of data contains the same number of numbers in it. It's just distribution is different. Okay. So one way say percentile, which means exactly the same thing. If they ask you where is 25 percentile, 25 percentile, which is here. First quarter is 25%, right? Where is the 75% percentile, which is here? It's just a answer with this number 55, or in the homework, probably they ask you to click on the graph. Where is the 75%? Click on this vertical line. You don't have to be 100% exact. As long as it's really, really close to this vertical line, anywhere close, click on that. Even in here, close to this vertical line, you're going to be right. Okay, 75 percentile, 50 percentile, and 25 percentile. And the spread, we already mentioned that spread represents the distance from the lowest to the highest. For example, the spread for the third quarter of data, spread is not a number, it's a range. Spread, right? That's a range. So what is the spread for the third quarter of data? Third quarter is here. First quarter, second quarter, third quarter, fourth quarter. Third quarter has a spread from 30 to 55, and that is 25 points. That's called a spread. The width of each quarter is spread. Okay, good enough. Now we can answer this question now. It's very similar to the one that from the book, from the homework. So we are given this box plot. We need to answer these 2 questions. First, which quarter of the data has the smallest spread? When they say quarter instead of quartile, it means a range of data. When they say quartile, it's a number, actually, a single number. This is 25% quartile, which is 30, 50%, 75%. Once they say quarter, it represents this area: first quarter, second quarter, third quarter, fourth quarter. Each quarter contains the same number of numbers of your data set. So since they ask us about spread, we look at the width of each quarter. Which one has smallest width of these 4 quarters? Apparently, this part is the shortest width. So this is the third quarter. So we say quarter, not quartile. quarter 3. That means actually this means this third quarter represent the most concentrated area because each quarter contains the same amount of data, and this width is narrower. That means this is way more crowded than the other 3 quarters. Same number of numbers are crowded into this narrow range compared to the same number of numbers spread out with big range. So that's why we call it describing data. This box plot is a way to describe data. So which quarter of data has largest spread? Apparently this one is longest, fourth quarter. So your answer is quarter 4. So that's it, that's the answer. Now the next one is the last one for this video. This is from homework. I pulled it out from the homework pool. The box plot below illustrates the heights in inches of 15 randomly selected National Basketball Association (NBA) players. That's their heights, and 15 randomly selected NCAA players. So basically, this is a comparison of the heights from 2 organizations. So apparently, by this graph, first box plot is describing the heights of 15 NBA players, and this one the heights of NCAA players. Now that we can see a lot of different things when we compare this two. We can compare median to median, lowest height and to the lowest height from different organizations, highest to the highest, right? Third quartile to third quartile, all of kind of, you can even compare between median and the first quartile. Any 2 numbers can make a comparison. So there could be many different conclusions. But the thing is, we only need to answer this question, select the valid conclusion based on the data illustrated in this plot. So we are given 4 different conclusions, and only one can be correct. So let's read through them one by one. And then after we read each one and we compare this statement to the graph to see if it is true. So the first one is that the median height of a NCAA player is very close. So this is the median height of NCAA, which is about 76, looks like. It's very close to the third quartile height of NBA. Are they really very close? Apparently it's false. You cannot say 76 inches close to like 81 inches. That's not close in terms of height. Now B, the median height of an NBA player, now we're talking about this one. Let me use a different color. And the median height of NBA players, are talking about this one. And it's very close to the third quartile of NCAA player. Third quartile is here. Well, that's kind of true. Oh, that's really close actually. Now, before we pick this one as answer, we want to also double check the other 2 to see if there is even more, even more correct, even though that's not very appropriate to say that if correct is correct, if not correct is not correct, right? We don't say more correct, but as long as you understand what it means, that's fine. Say better candidate, right, as the answer. The third quartile height of NBA, which is this, is very close to the fourth quartile, which is the third quartile of NBA is very close to the first quartile of NCAA. That's far away. They are really far away. That's not true. So the last one, the median height of NBA, which is this, is very close to the median height of the NCAA. That's not very close. So only second one is very close to the truth. So the answer is B in this case. So it says the correct answer from the blackboard. The median height of NBA player is very close to the third quartile, of the NCAA players. That's B. So that's our answer. So this whole question is created to test if you understand each part of this box plot. What this mean? What this mean? What this mean? What this mean? Right? If you understand that, you can read the plot and you can make the comparison. Okay, everyone, this is the end of the end of this video.